Hey, okay, for this one, the method I would choose would be substitution. You could do either one, but I would choose substitution because this equation already has a variable that's isolated. So if there's already a variable, so like one of the letters is alone, so this guy is all by itself on one side of the equation, then substitution just seems easy. So since this one's the one that's isolated, the y, I'll use my other equation, 3x plus 2y equals 14. Okay, so this y right here, I'm going to put it another color, make it red. So I know that that y is, I'm going to sub my equations into each other. So this equation over here, the y in this equation is equal to 5x minus 6. That's what y is equal to. So like y is actually equal to 5x minus 6. So I can actually take that 5x minus 6 and put it in the equation for this y. So I'll write my equation, 3x plus 2. And then wherever there's a y, instead of a y, I'm going to use the y from the other equation. So 5x minus 6 equals 14. So I'm subbing my equations into each other. And now you can see the reason I did that is so that I just have one variable. So now I just have x's. So I'll simplify it. So I have 3x plus, I have to multiply everything in the bracket by 2. 10x minus 12 equals 14. Now I'm going to collect all my like terms. So I have 3x plus 10x, which is 13x minus 12 equals 14. Then I'm going to say I want my x's on this side, and I want all my numbers on the other side. So I'm going to add 12 to both sides so I can get rid of, I'm going to use my highlighter just so it doesn't erase, but I want to get rid of those 12s. So now I have 13x equals 14 plus 12, so 26. And then I want to get rid of the 13, so I can just have an x, so I'm going to divide by 13. So now I know x equals 2. But I'm trying to find the point of intersection between these two lines, so I need an x and a y. So my next step, I can use either the red or the green equation, doesn't matter, just one of the two original equations. So I can use this one or I can use this one. And I want to find out what y is. So I'm going to use the red one. So I'm going to say y equals 5x minus 6. And I'm going to sub in my x value. So 5 times 2 minus 6. So y equals 10 minus 6, which is 4. So therefore, the point of intersection is 2, 4. And that's substitution. Let's try a different question.
But seriously.
Question 2. Which method would you choose to solve? For this one, I'm going to use elimination. And the reason I'm thinking elimination is because see how my x and my y here, they have a number in front of them, so like a coefficient, and same with this one. Everything has a coefficient. So for substitution, you want to isolate a variable, and that looks like it might be hard in this case. So I think elimination would be better. So for elimination, I'm just going to write my equations on top of each other. So 2x minus 3y equals 3. And I'll write my other one in blue, 3x minus 5y equals 3. Now for elimination, you have to make sure one of the coefficients is the same. So let's look at the x's. This guy's a 2 and this guy's a 3. So they're not the same. Let's look at the y's. This one's a 3 and this one's a 5. So they're not the same either. So it doesn't matter which one, but you need to make one of them the same. So let's make the x coefficients the same. And all you have to do is multiply the equations by something, and it can be anything. So I see a 2 and a 3 here, and I think, you know what, I'm just going to multiply this equation by 3, because that will make it a 6x. And I'm going to multiply this equation by 2, because that will make it a 6x. So then they'll have the same coefficient. But I can't just multiply the x's. I have to multiply everything in this equation by 3 and everything in this equation by 2. So I'm going to end up with, for my purple one, 6x minus 9y equals 9. And then for my blue one, 6x minus 10y equals 6. So I just multiplied the top equation by 3 and the bottom equation by 2. And now, since I'm using elimination, I'm going to either add or subtract my equations. So my goal is to eliminate these x's. So since I've made them the same, they're easy to eliminate, because if I just subtract the equations, I know that 6x minus 6x will be 0. And then I just do the same for each column. Negative 9 minus negative 10 would actually be 1y. So I'm just going to write that up for you. Negative 9y minus negative 10y is what we're doing. So negative 9y right here, subtract negative 10. So that would be the same thing as saying negative 9y plus 10y, which equals 1y. So that's how I have a y there. And then finally, 9 minus 6 is 3. So I just figured out that y is equal to 3. But I also need to know what x equals. So I go back to my original equations, this one and this one. And you can pick either equation, doesn't matter. So I think I'll pick this guy. So I'll write 2x minus 3y equals 3. And wherever I see a y, I'm going to replace it with a 3, because that's what y equals. So 2x minus 9 equals 3. And then I'm just solving an equation here. So I'm going to move my 9 to the other side. And I don't know how you do that, but I can't stop that box from, okay, there we go. I'm going to add 9 to both sides, because then that gets rid of that. So now I have 2x equals 9 plus 3 is 12. And then I'm going to divide by 2 to get rid of the 2. So x equals 6. So I know, therefore, the POI is 6, 3. So that's where the two lines will intersect, and that's elimination. I think I put one more. So if you feel like you need another one, keep watching, and if not, just turn this off. Okay, this one I just thought was interesting because they both had y's isolated. So you could do substitution or elimination here. I personally would do substitution, but you could do either one. So for substitution, so see how this one has a y. Actually, they both have y isolated. So for this, I know y is equal to 2x minus 3. So I'm actually just going to take that, and wherever there's a y in the other equation, that's where I'm going to insert that. So I've got y equals x plus 1 for this equation. But instead of this y, I'm actually going to replace that y with 2x minus 3. So I just subbed my y into the other equation's y. Now I'm going to get my x's on this side and my numbers on the other side. So I'll just do that in one step. I'll do 2x minus x, because I'm just subtracting x from both sides. I already have a 1 over here. I'm just adding 3 to both sides so I can get rid of the 3 from the negative 3 from the left side. Okay, so I just moved my stuff around. Now 2x minus x would just be x, and 1 plus 3 will be 4. So I know that x is equal to 4. Now I just go back to either equation. I'm going to pick this one because it looks way easier. So y equals x plus 1. And I'm just going to sub a 4 in for x. So y is equal to 5. So therefore the point of intersection is 4, 5.